With any luck, you'll get some time to work on homework today as well. 431, actually due by the end of the day. 65% of you have already turned that in. It is sad, but Franco's been gone for so long. He does not count towards your class total. So you guys, actually, what we've been operating on is a total of 20. So each of you is worth 5%, right, is really what this comes down to. If there's 20 people total, each of you is worth 5%. So 65% of us already turned in 431. If you haven't, you could come to math lunch today and get it done and turn it in before the end of the day. Because that percentage is going to go up, right? That's not your final percentage. Somebody asked me, what does TBD mean? That means to be determined. It means we got to figure out who wins after you guys turn in more homework today. So on your graph paper, go ahead and draw this shape right here. And I want you to label the perimeter all the way, like the X's and the ones, and there's a trap door up here. There's one of the more difficult ones. So be careful, but label everything around this shape. My spare highlighters are up here. Oh, it looks like you might be lucky. I got green. Purple. Yup. Ah! I overthrew. My toe was too high up. Hi. Hey, again, this is not going to sound like what maybe your math teachers in the past have told you. If you're done with 431 and a classmate isn't, help them. Don't do it for them, but help them out. Right? We're all in this together, so if a classmate needs help and you know what you're doing, help them out. You all right there, Vincent? I know that calculator was hanging out on that desk. So then, talk with your team. What is the total perimeter of this shape when you put the like terms together? When you put the like terms together. Still no Jesus today? We got to keep going through the deck because I did not make it very far. Ooh, Ben's up here, by the way. Sorry, Ben was kind of blocked by my lunchbox. So you need to turn in 431. So Layla, can you tell me what I was talking about with the trap door? Which side up here is kind of dangerous? Yeah, I should have specified which Layla, my bad, because you were like all ready to go. Probably the what? Ooh. So this side is a little dangerous because it's going to be what length? X minus 2. Please make sure you have that labeled on your graph paper as X minus 2. John? Nah, because I'm doing cards for that. Thank you. Ooh, the other Layla Graph. I can't believe you guys are right next to each other in the desk. Layla Graph. Sorry, you're both the Laylas. I didn't mean to say the other. But what is this trapdoor's length? Yeah, X minus 1. Kylie, what is this length right here? The top of an X squared. We got one here, we got one over there. Yeah, X, the length of X, right? The edge of X squared is a length of X. Dikshita, what about the top edge, or like what looks like the short edge of the X tile? How long is that? 1. Ooh, we're going to step it up here. Vincent, what about around this corner? 3. And then if I add the bottom? 4. Ooh. So either you should have 1, 1, 1, 1. Or if you put them all together, there is 4 around this corner. Right? 1, 1, 1, 1. Or you could say 4. Oh, no. Gravity works. Isabella, what about, if we just keep going in order, what's this length right here? 1. Yeah, 1x, right? Or we can just put x. Lucas, what about around this corner? You're good. Take a moment. Or pass if you want. You're good. You're good. Farah. Boom, 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 boom. 4. So I could do 1, 1, and 2, or I could just say 4. All right, so now let's put those all together. How many x's in total? 1, 2, 3, 4. Guys, remember the minuses? They don't stop x from being x. X is still x, even if it has something minus from it. So we got 4 x's. And then I like to do positives first. How many positives do we have? 4, 8, 9, I think. And then 9 minus 1 takes us to 8. Minus 2 more takes us to 6. So if you want to write it out, I might write out 4x plus 9 minus 3, right? And then do the math, because that's just a little bit easier to think about. Here's your challenge, though. Does x stay the same all the time? No. So just like my little arts and crafts over here, we're going to play with what happens when x changes. Solve this for all 4 different values of x. So I'll write them bigger. For those of us that are visually impaired, I'll write them bigger up here. What about when x is 5? What about when x is 3? When x is 2? Hopefully time doesn't stop again for us today. Guys, time stood still yesterday in here. Each of these should start with 4x plus 6. And then we'll plug things in. Should be talking with our team. It's like too quiet in here. You're creeping me out. Talk with each other. Do math with each other. Yeah, if you're trying to make your paper look like mine, that's real. I don't even know what to say. It makes me real happy. If you got 4 different columns where you're solving this the 4 different ways. I don't know. I have not drank any water today, so I should probably do that. Well, there's water and coffee. I just don't think it counts. Now, some of you are skipping this step. And if you're, like, really comfortable, that's okay. But I would prefer to write out the word just to make sure that we don't make any mistakes. So when we substitute x being 5, we're multiplying, right? So, Katie, you want to talk me through here how we do 4 times 5 and then plus 6? It's like, what's 4 times 5? 20, and then we add 6 to it, so what do we get here? Yeah, if x is 5. If x is 5, our perimeter is 26. But that doesn't stay like that, because then they're like, wait, what if x is 3? So, Vanessa, you want to talk me through that? Huh? 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 Careful, the end answer or like a halfway answer? Yeah, so this 4 times 3 is 12. Then we add 6 and we get 18. Jesus is not here. Antonella, where you at today? You want to talk me through this one? You can always pass if you haven't had enough time to get to it. You're good. Sure, John. It blank one. I still have blank ones in here. I use them for different stuff depending. Ooh, yeah, this is 8. Yeah. So guys, remember, order of operations, it matters that we do the multiplication first. And this, if you were wondering, this was literally your card. I try to stay true to the cards when I'm using the cards. Marina, you want to walk me through the last one here? What happens when we multiply by 1? Yeah, it's just the same. So then we get, in the end, 10. Guys, this is the most complicated part and where people like to make jokes about, like, why does math always try to have us find its x? And then there's like a relationship joke or whatever. Like, x is always going to be changing all the time. Like, we could use different letters, and I kind of wish we did, but x does not stay the same. Okay, x is just, it's different in almost every single problem. Does that make sense? X is some length that changes, some distance that changes, and then it can become area. So now, what I told you about yesterday, the distributive property, now we're finally going to get to doing some of that. I got a trick. And some people like to think that math is like mystical and like those people that don't really necessarily understand math. There's no magic involved. Actually, when I was a kid, I still believe in magic. But when I was a kid, I really liked watching magic, and I didn't know how they did it. Then as I understood more math, I was like, oh, I see what you did there. Careful. Think of a number. On your paper, write down that number.
We did this.
Yeah, and it's on like almost every magic show.
I feel
All right, so your number, right? Whatever your number is, triple it. Now write down that new number, right? Ooh. Yeah, if you need to go back and reevaluate your first number and make it easier to deal with, you can change your first number. But all right, take your number, triple it. Okay, we did that. Now, add 1. Then, multiply it by 2. Now, there's actually a way that people will like think is magic that gets us right back to either our starting number or a specific number that we all end up with the same number. You ever do the one with like pick an animal that starts with that letter and pick a color that starts with that letter? And we'll do more of those later in the year. But I'm going to leave you kind of on the cliffhanger here because we're not going to finish this trick. We're going to try to write this out, right? Because this is not magic. It's just math. Most magicians, probably all, I don't like using the word all, most magicians are just using math. How would we write this out? So if we had x as our number, how would we show tripling x? Times 3, right? So a multiplication by 3. Then add 1. Ooh, I could use parentheses. If I don't use parentheses, will that still do the tripling first? Yeah, because order of operations, right? And then if I want to multiply that new number by 2. We would have to do parentheses because to get the multiplication by 2 to hit the whole new number, we'd have to put that in parentheses and do a times 2. Go ahead and write this out on your paper. with the x. And if we look at it just like this, this is the distributive property. And the reason why the distributive property exists, can I put 3x with 1? Can I put them together and just say, oh, it's 4 or it's 4x? No! I can't add 3x and 1. Let me write it differently because this is how we've been writing it. 2 times without the multiplication symbol. Right, so if we think about that, we've got 3 of these guys, right? 3 of our x's. 3 of these guys, and 1 of the 1 tiles, right? And then we're going to double the whole thing. Well, how many x tiles would I end up with?
Wait, no. Oh my god.
Here's a trick that I decided in the past couple years I think I like better. Most people, when they distribute, put arrows up here. You could also draw arrows down here, and I think that makes a little bit more sense. Draw an arrow from your 2, go into the 3x and go into the 1. If I double the entire set, what is double 3x's? 6x, right? If I double 3x's, I get 6 of them. And what would be double the 1? 2. All right. So go back up your paper to where you had your number. Right? The last number you had. The number after you multiply. There's a ghost in my classroom, guys. Like something's happened. So this number, right? This number. I'll finish the trick now. I bet I can get you back to your original number. And not by just like undoing those steps. I'll give you a chance to make a guess though. Anyone want to guess how I'm going to get you back to your original number? John? I can't say no, because I could do that. Yeshida?
Divide by the original number.
No. No. Kylie?
Huh?
Huh?
Divide by 6.
Ooh, why?
Because if you have 6 of the x to begin with, once you do all that, you have 6. You have 6 of the x's. If you divide by 6, it should get back to its original number.
You're right, but we have to do something else
You
first.
also take away the 2.
So your number that you have right now, subtract 2 from it. Subtract 2 from that number that you have. Now, like Kylie said, divide by 6. And if you did your math right, you should get the original number back. Guys, this blew me away when they did it on TV. Because they're on TV. They're like, they don't know me. They don't know my number. And they used to do this stuff on these magic shows. I was like, what the hell did they do that? How in the world? They got my number. And then they figured out that I had a purple elephant in Africa. And like that's a trick. And you can outsmart that one. You can't outsmart this. So guys, who's got like a little or big brother or sister at home? Who's got a sibling? If you go home, guys, I loved making bets with my siblings. Because, we'd bet candy, we'd bet like $1, whatever. Guys, if you go home and do this to somebody, let's try it again. New number, different starting number. Pick a different number. Pick a different starting number. So I'm going to pick 7 because I like that number. All right, let's try this again. Take your number, triple it. Take your number, triple it. Triple it. Hold on. Then add 1 to it. And then double it. So you started with your number, you tripled it, added 1, doubled it. Now, subtract 2. Ghost. When my screen moves on its own, I'm telling you, ghost. Subtract 2. And then divide by 6. And you will get back to that original number. Guys, you have my absolute permission to go home and place wagers with your siblings. However, they got to do the math right. Right? If you mess up the math, you won't get back to your original number because you messed up the math. John?
So I did negative 5.5 for the first one.
Okay.
Hold on. And I tripled it, which I think got me 17.5, right?
Yeah. But positive or negative? Negative.
I added 1, which got me 16.5.
Negative.
And then I multiplied it by 2, which got me negative 33.
Okay.
Then I subtracted 2, which got me negative 35. And then divided by 6, which gave me 5.833333.
So I wonder if there are certain numbers this won't work for.
It didn't work for mine.
This is called a conjecture. So in mathematics, when we have this thing we're playing with and we think works, it's called a conjecture. So wait, what other number do we think it didn't work with? Are you sure? There was a mistake in our work. So my curiosity with what you said, I'm going to encourage you guys to test it. I'm not going to test it for you. So you said a negative number. And everything I've done up here has been a positive number, so I don't know, maybe negatives make it fall apart. I don't know. We can come back to this and play with this more. I got another problem for us to do. On your paper, we're going to show 3 different things, and then I'm pretty much done, and we can work on homework. So write down 4 parentheses, 2x plus 3. Then we're going to do 12x plus 18. And this, what I wrote in green up here, is where some of you guys got mad at me with your homework. And this was like a week or 2 ago, so you probably don't remember it. Hopefully you've let go of any anger you have towards me where you came in and you're like, we haven't even learned about this. And I was like, yeah, I know. Your book has a glossary. You guys have Google. Sometimes I'll throw you stuff you haven't learned about yet. What we're doing on the left here, and I need your attention up here because this is actually where it's like critical that you don't know what we're doing. What we're going to do on the left is using those arrows and distributing the multiplication. But what we're going to do on the right is we're actually going to figure out what could we take out of both of these numbers and rewrite this like number times quantity something x plus something. So my challenge for you and your group is think about 12 and 18, and if instead of multiplying, we're actually going to divide to take a number out of them, what number could you divide both of these by? Take a couple minutes to talk about this. Try to write it out. Then you have another one if you want to try another one. And then if you get done with these 3 things, you can work on your homework until we come back together to talk about this. Okay, I'm going to give you a few minutes to work on this. So because you had missed class, feel free to copy notes from people or whatever. Come see me when you talk, okay? There will be a number out here. There will be a different number right here. And a different number right here. Well, compare it to what we had in blue. See if you can take what you did in blue and apply that to what we're doing in green. That make a bit more sense? What are we doing over here? Yeah, so we do 4 times 3x, and we do 4 times 2. That's why I drew the arrows. So make sure you draw those arrows. We have to do the 4 times in each of them. So actually here we're going to draw the arrows going this way, going from the 4. It's on the other one where we're kind of pulling them out of this. So what could 12 and 18? What's a common factor, I guess, is what we're thinking. I don't know, we're going to check it together in a second. Ooh, I like it. Carmen, you want to help me with what I have in blue up here? You're still working? Totally fine. Eli, want to help me with what we have in blue up here? Hey, Eli's talking now, guys. So we do the 4 times the 2x, and we get that we would actually have 8 x's. And then 4 times the 3 gets us 12. Guys, this is the trap door. You'll forget to do that. At least once, I almost can guarantee it, you'll get excited that you solved the first multiplication, and you'll move on, and you'll forget to do the second multiplication. So I'm telling you that, hoping that you'll prove me wrong, and don't make that mistake, right? Always remember to do both. Or sometimes there's 3. Sometimes there's 4 things that we got to multiply to. But then the opposite process here, Mia, do you know what we could divide 12 and 18 by? 6. So if we, guys, look up here. I'm going to show you how this works. You can write what you choose to write. 2 would also work, but we kind of like the biggest number that we can. So guys, what we think about, give me your eyes. Just put your pencils down for a second. What we think about is 12 and 18 can both divide by 6. So how we're going to then write that is if I do 6 times, how many x's need to go here to get back to 12x? 2, which is also the answer when we do 12x divided by 6. But then 18 divided by 6, what's 18 divided? 3. And guys, we can check it. Check it by doing the multiplication. Do we get 12x? Yeah. Do we get 18? Yeah. So this, and you got to write this because otherwise you're going to see it on your homework and you're going to be like, wait, what? This is what we call factoring. If you are asked to factor an expression, you're being asked to pull out really the biggest number that we could divide both of them by. Think about this like making gift bags, right? Like I have a bin full of 12 ornaments and 18 pieces of candy, right? If I want to say, well, how many people can I evenly share these things with? 6 is the most amount of people if I want to split these things up nice, right? Unless I start cutting pieces of candy in half or start like, that's the biggest number I can divide both of these by, right? Because 9 wouldn't work for 12. It would be a decimal. Yeah, 2 would work, right? I could invite just 2 people to my party. Hold on, so let's play that out. What if we did 2? Because that works. What if I only have 2 people coming to my party? Let's do it. You don't have to do this on your paper, but if I divide by 2, the 2 goes out here. Goes. Okay, I got people talking, and I'm worried that we don't quite know what we're doing yet. This would be 6x because 12x divided by 2 is 6x. Plus, what's 18 divided by 2? This would also be a factored form. There are multiple right answers. But if we factor out the 6, that's the most people we could invite. Yeah? right now, I just want to see that you can factor. Eventually, we want this number to be as big as we can, but still a whole number. No, mini mastery is about proportional relationships. Nope, mini mastery is about proportional relationships. Guys, I'll tell you right now, essentially what you're going to be dealing with tomorrow is like, I need to lay some floors in my house, and let's figure out how much it's going to cost. Yeah, so like if I didn't talk about this in this class, I mean, I already did it. But so this is the flooring that I bought and installed in my house this summer. It's click lock, tongue and groove. Yeah, it's sold at Lowe's. It's nothing super fancy. I made the price of it easier because it was like $379, but that's not fun to work with. So I made it $350. But like our mini mastery is essentially going to be talking about this. If I buy 0 of this, what would it cost? 0. Would this be proportional? Yeah. Hey, look, I'm giving you answers for the test right now. 10 plus 15x. If you don't like how it's written, could I write it like 15x plus 10? Yeah, because what property says I can move numbers? No. Commutative. Commutative says I can move numbers when we're multiplying or adding. Right? Factor this. What's the biggest number we could divide both of these by? And I did not say, yell it out to the whole class. Guys, I'll say it again since we're all in here. Because I was grading papers last night, my wife goes like, what happens if they get to 100%? Because I told her about the homework competition. I was like, well, that's a really good question. Because she's like, because then, like, they can't lose, right? Like, so what if they all turn in their homework? Like, I guess they all win. Like, if every class gets to 100%, or any class that gets to 100%, you just win. Right? So, like, 2 classes could win, but if you guys get to 100%, you win. You get your 3rd victory. So, again, help each other out with your homeworks. Come to math lunch if you want, AO, extensions. My AO is gone today, so you can come do math with me. Right? Like, my AO is in gym. My AO group is in gym. Class, what's the biggest number we could divide both of these by? 5. So if we do that, and guys, if you would rather write divide by 5 separately, you can write it separately. That's fine. But now we're going to say it is 5. Ooh, come on, change color. Ghost. 5. If I do the blue one, how many x do I still have? When I divide, we get 3x plus how many constant? 2. If I write it over here like the green, we have 5 on the outside. Same thing on the inside, just other order. 2 plus 3x. Questions? Dang, that's it. Yeah. Oh, one more. Whoa, this is probably going to feel E-word. Probably going to feel E-word. 21x plus 7. Talk with your team. What could you factor out of that? What could you divide both those by? You put out front. How many people can we invite to our party? Split things up evenly. No. Now we're just going to make up synonyms. Easy. I'll let it slide. Because really what I care about is other people hearing you say. I mean, what if we say it in Spanish? Like, what if we, isn't it fácil? Yeah, fácil. Okay, well, we could go in Espanol. Cuando, crap. Yes, it's a cuando numero. It's not gonna be good. That is me trying. Quando que numero? Que numero? That's what I'm wondering. Que numero? I don't know how to say divide. So cinco, yes. What'd you take out of both of these? You said it as soon as we started. Siete, it's 7. So 7 can come out of both of these. So 21 divided by 7. Ooh, let's go ahead. This is the other mistake you might make. Make sure the number you're dividing by you put out front. Yeah, thank you. And 21 divided by 7 is 3x. And 7 divided by 7 es uno. Muy bien. All right, do your homework. I love it. Love it so much. I'm done if you need help. Yeah, let's do homework problems with the time we got left. 98.432. Wait. Oh, yeah, because it's 2 pages. Or, like, whatever. Or maybe I tweaked it. Alright, friends. DJ Hudcap is back again with some requests. Nah, I'm talking about math requests, sorry. I know, so disappointed. Alright. Remember that I was being critical about, guys, pay attention when there's multiple parts of the question. Area, if you look at 98, we're looking at 98 together if you don't have it done. What's the area over here? Well, the area is the names of the shapes, right? X squared plus x. But perimeter, we got to walk around the shape. There's a trap door. This is actually kind of interesting here. Because what's this length? X minus 1. So we have a minus 1 and we have a plus 1. What's going to happen with the positive 1 and the minus 1? Yeah, they're going to zero out. So I have 1, 2, 3, 4, 5, 6 x's. 1, 2, 3, 4, 5, 6. Yeah, 6 x's. So our perimeter is 6x. Yeah, I mean, we haven't checked the answers for 432 because it's not due yet, but sure. So then, guys, if we've already said area is x squared plus x and perimeter 6x, down here, you're allowed to just show me the work of area equals 7 squared plus 7. But guys, let's talk about what this means. If the x is 7, this square is 7 by 7. What's 7 by 7? 49, right? It's 7 times 7, so it's 49. And then this rectangle, sorry, I should move my mouse. This rectangle is 7 long and 1 tall. So what's 7 times 1? Thank you, because you're actually listening to the question I'm asking. John's trying to give the final answer. So this one would be 7, and together, yeah, man, we've heard you. But it's area, so what label? Units squared. You gotta have the U, guys. You can either write units or you can put the U. You gotta have the U. So perimeter is going to be slightly easier math. Crap, I should have written the 6 first. Sorry, 6 times 7. You're close. You're close. What's 6 times 7?
It's 42.
42 units. No, the perimeter is just 6x.
Oh, yeah.
Remember, the positive one and the negative one zero each other out. That positive one and the negative one zero each other out. So our perimeter is just 6x. Now, we're probably going to need a calculator for part B. Yeah, we're almost out of time. Because this is going to be 2.5 squared, which is kind of tough to do. Plus 2.5. Hey guys, I'll go ahead and tell you to save you time grabbing a calculator. 2.5 squared is 6.2. Sorry, this is area. I wrote the wrong thing. Area. 6.25 plus 2.5. 2.5 squared is one that I guarantee you probably don't know yet. But 25 squared, you'll learn eventually. 25 squared is 625. That's how I know what this is. I don't actually know what 2.5 squared is. I know what 25 squared is. So we'd add those up. For perimeter, it'd be 6 times 2.5. And again, grab that calculator. But alright, that is all the time I get with you guys. So, have a wonderful day. If you'd like to do more math lunch, AO, or extensions, you can make my day by letting me do more math with you. Come do math with me. Please, I beg of you. I do sound desperate. I'm hungry is what I am, Eve. I'm hungry to do more math.